we talked about continuous random variable, which is shown in the picture. So the difference between discrete and the continuous is the discrete variable you can count, or you can make a list. It's like 1 or 2 or 3 or 5 or 10. So that's for each number you have a probability, a percentage. Say how many TV sets we have, say maybe the percentage of families which have 3 TVs is maybe 30%. So it's a discrete number, 1 or 2 or 3. But for continuous random variable, it's not a you cannot make a list, because say the baby, the birth weight, it may not be a whole number. It could be 6.1, 6.2, 6.3, 6.34, 6.344, and so on. So it's going to be everything, every number, real number. And so that's why we cannot make a table for the probability. We have a curve, a continuous curve. It's called a probability density curve function. So if we want to find out the probability of of something, say the baby weight between 6.6 pounds and 6.5 pounds, we have to calculate the area under the curve from between 6 and 6.5, which is difficult to do. Again, we have to use calculus. So what is there any way that we don't have to use calculus? Yes, we have a table which has been calculated by the statisticians that we can use. Okay, so what we do is, if we have a continuous random variable, we can convert it to a standard variable by using this formula here. So this formula is on page 229. X here is again, like before, we always use X for a random variable. It could be for discrete case, it could be anything like a whole number, 0, 1, 2, 3, or so on. In this case, X can be any real number. It could be 6.1, 6.2, 5.7, anything. And so when we have a variable, a random variable, we will find out if we know the mean, mu, we use mu for mean, it's the population mean, and the sigma for the population standard deviation. And if we know that, we subtract mu from the variable and divide it by standard deviation, which gives us a variable. We call it, we use the letter z to denote it, and we call this standardized variable. And the reason we're doing this is we will convert this to a dimensionless scale. For example, if we have a random variable x that is the real estate salesperson's commission for a month, and it could be 4,000 or 5,000 or maybe $4,329 and so on. But it doesn't matter. So x is a random variable, can change, and it could be 4,229.37, anything. So we will take this, but we can calculate. For example, we calculate the average, or you call it mean, and that is $4,000 for the whole year, and the standard deviation is 500. So for the whole year, sometimes 1 month this salesperson makes maybe more than 4,000, sometimes below 4,000, but the average is 4,000. So what we do is we take 1 month, for example, the third month, what she makes, or the first month or second month. So it's a random. It could change. So we use a variable x to denote it, minus the average for the whole year, and divide this by the standard deviation, divide by which is 500. Suppose we have calculated this, and so this is what we call the z variable by using the formula. So the z variable, how do we calculate it? X, what x means is whatever. In this example, it's the commission the salesperson makes for each month, minus the 4,000, the average of the whole year, divided by the standard deviation 500. So this is converted. X is converted to standardized variable. Okay, so it's like X is how much money she makes minus 4,000. So it's like the difference of this month. Subtract 4,000 difference from each month, and to the average, and they still have a dollar, and divide by $500, and then the dollar kind of cancel out, so we have something without any units. So we don't care about dollars or anything. So now it's like a dimensionless scale, and we can use, when we have convert a variable to a standardized variable, and we can use the table to calculate the probability. So for example, what's the probability of the salesperson making more than $5,000 a month? And then we can calculate it. Or what's the probability of her making less than $2,000 a month? So for the homework problems, 6.9, and that's what you do. So whatever, they always tell you mean and the standard deviation. Sometimes they tell you variance, and then you gotta remember the standard deviation equals the square root of the variance. So if I tell you the variance is 16, then the standard deviation will be square root of 16. That's 4. So that's something we have learned before. And then you can plug into the formula. So this is the answer. What is the standard deviation? It's if I tell you mean equals 4,000, and the standard deviation is 500. How do you find the standardized variable? This is the answer here. So X, we always use X to denote the standard is to random variable, and this random variable minus the mean 4,000 divided by standard deviation 500. So that is standardized variable. And in next few videos, we're going to explain why we're doing this, how we use this to find out the percentage or probability of something.